All right, well,
Turning 18 or 19?
Javon had a good weekend. That's really good. Now everyone on the internet knows that. Hi, Caroline.
Hi.
You're gonna do calculus with us today?
Grow your beard.
Yeah. It's still growing.
No, I'm okay. Jump
Sure.
in here?
No.
But A is.
I need video sound.
Shouldn't you be in class?
Yeah. No, but he left me. He told me go get it.
So do I have a laptop charger for this young lady?
Why do you need a laptop charger?
Maybe her laptop's dead.
Like the card.
Do we have a test today?
No.
No, but you do stuff on your computer.
Just make sure.
Does anybody have a laptop charger?
I don't have one.
No.
Yeah, no. But it'll be trimmed tomorrow.
Why?
Bye, Caroline.
Dude, you gotta grow it out like
See you
full.
in an hour.
Huh?
See you in an hour. Yeah, that's right. I know you're excited. Bye.
Dude, expand on your Jewish roots, man. You gotta
Just grow it real full.
Yes.
Alright, today we are going to learn
You
the
sound perfect.
trapezoid rule. Okay, so,
Bye.
whatever helps you to learn.
I'm trying to be funny.
Alright, so,
So, the trapezoid.
well, to begin actually, rather than going straight to this, what is a trapezoid?
It's a what's it called? A
Polygon.
four-sided, yes, polygon.
4 sides.
Two sides are parallel,
the
two sides are
yeah,
not.
the two opposite sides are parallel.
2 sides are parallel, 2 sides are not parallel. Okay, so, good. If I want to find the area of this trapezoid, I'll say this is B1, and this is B2, and this is my height here. Right? And the area of this trapezoid equals what?
One half B times H.
1/2 height times B1
Oh yeah,
plus B2.
the sum of the
Right?
yeah.
Cool. Alright. So that's the area of the trapezoid. I think we all kind of remember that, right? More or less. Good. Now, so I'm going to keep this equation right up here. I'm going to draw my trapezoid a little bit differently though. I'm going to draw it like this. Call this B1, B2, height, the area equals 1/2 height times B1 plus B2. Okay. Now, the reason why we're learning about the trapezoid polygon
Really random, but I like your capital T's. is we want to find the area under this curve, but we want to do it in a way that's a little bit more efficient or accurate, I should say, than what we've done in the past. Now, in the past, if we wanted to find the area under this curve, we would say, okay, if this is A here and this is B, and I want to find the area from A to B, and I have N, what I would do is I either look to the right, like this, or I'd look to the left, and I draw rectangles, right? So that would be what? Looking to the right, right? The right side, looking to the right.
I could also do looking to the left, which would be like this. So I could be looking to the right or to the left. But the truth is, neither of those methods are really that accurate because I'm either cutting off a bunch of area or I'm adding a bunch of area, right? So does anyone have a suggestion as to what I can do to make that a little bit more accurate?
Something dealing with trapezoid.
Yeah. Take a look at that trapezoid and then think about what I could do.
Oh, you make a trapezoid? Like you slant the top line?
Yeah. So instead of taking the lower sum or the upper sum, or looking left or looking right, I kind of do the average, which is by making a triangle from the left to the right. Now, pretty clearly it's not going to be perfect still, but can you all tell that that's definitely going to be better
Yeah.
than looking to the left or looking to the right and drawing rectangles?
Yes, sir.
Very good.
Way more precise.
More precise, more accurate. All right, so the question then is, how do I find the area using this method?
Well,
Let's make it a little easier to see by erasing our other lines. Right? So I have these 4 trapezoids, right? So let's say I don't exactly know I have 4, okay? Or let's do a real example and then we can do a general example. Rather. Okay, so I'm going from 0 to 4 is my interval, let's say, and I have 4 rectangles. Okay, so how I find the area of a trapezoid is I multiply 1/2 times this multiplied by this times this, right?
yeah. And H would be the interval over number of rectangles.
Exactly. So let's call this fx1, fx2, fx3, or I'll call this x1, I apologize, x2, x3, x4, and x5. Okay? Doesn't differently work. I apologize. Make this instead of x1, x2, just make it x0 through x4. So x0, x1, x2, x3, and x4. Okay? So, first thing I want to do is find the width of each trapezoid. So I want to solve for height, right? Because the area is 1/2 height times b1 plus b2 for each trapezoid, right? So let's find the area of each one of these trapezoids. And then when we find the area of each one, what will we do? Find the total area?
Yeah.
When you
Yeah.
Add them
oh,
up.
you add them.
Add them up.
The summation.
Yeah. So we'll say this is 1 or 2, 3, 4. Okay. So area 1 will equal, well, let's see, let's find our height first. What's our height? How do we find it? You're going to consider that for the interval over the number, right? So it's 4 minus 0 over the number of
trapezoids, or number of
Oh,
intervals.
yeah, trapezoid.
So it's 4 over 4, so the height is just 1. Pretty clearly here, but it's not always necessarily that clear.
Wait, why are we, I forgot, why are we subtracting 0? Like, what is that number supposed to represent?
It's the end of the interval. We find the width of the
Oh,
interval.
okay, like in case
right?
it doesn't start 0.
Yeah, if it
Got
started at 3 or something, then it would
Yeah.
make more sense. But here I just do the end of the interval minus the beginning of the interval over the amount of intervals, or the amount of trapezoids. Okay, so that's my height. Now that I found my height, that's the height for all of them, right? Or height is kind of misleading, but that's this width, right? Does that make sense? The width of each pen?
Yeah.
Of each one. Alright, now I want to find this length and this length, because that's that and that. And then I have my B1 and B2, right? So let's find the area of 1. So it's going to be 1/2 times 1 times, what's B1 in this case?
0.
F of x0, right? Because this point here is f of x0. This point is f of x1. This point is f of x2. This is f of x3. And this is f of x4. Okay, so this height from here to here is
Which height?
this one here,
F of x0.
f of x0, and this height here is f of x1. Good, so we have our first one.
Wait, do we get a function?
What was that?
Do they give us the function?
Yeah, they would have to give you the function. Yeah, for sure. Or at least the heights at the different intervals. They might not give you the actual function, but they'd say, this is 2, this is 4, that's 5, that's 7, that's 9, something like that. Okay? Alright. A2. 1/2. The width is still the same, right?
Yeah.
But now, what's my base 1? What's this? F of x1 plus f of x2. Okay. Might be able to see the pattern now. The next one, the third, is going to be 1/2 1 times what? F of x2 plus f of x3. And the last one, A3, is going to be 1/2 1 times f of x, what? 3 plus f of x 4. Good. Now, my area total equals what? Add them all together. A1 plus A2 plus A3 plus A4. Okay? So let's do that. But look, they're all multiplied by 1/2. So do I have to do 1/2 times this plus 1/2 times this?
No,
Or
you
can I
add
just,
them up and divide two.
right, I can just keep the 1/2 on the outside, right? Does that make sense? So it's 1/2 times, I'm going to keep that 1 there just so we don't get confused, even though it's just multiplying by 1. I want to make sure that we remember that that's really there. So it's
Is
1/2.
that
What was
area
that?
7? Like, what's that subscript? Or under the A, like from A?
A
something?
total, I apologize.
Oh, okay.
So A total equals A1 plus A2 plus A3 plus A4. So it's 1/2 times 1 plus now all of these terms in the inside, right? So I have f of x0 plus, look, I have f of x1 and f of x1. So I'll just say 2f of x1.
Wait, can you repeat?
I have f of x1 plus f of x1. Does that make sense? No?
Gotcha. Yes.
Yeah. So instead of just writing f of x1
Because
plus
you're just
f of
adding
x1,
all the.
I'm just adding them all up. Should I not skip
But
that
I
step?
mean, but
I mean, just
even though you do that, it's okay to not do
let me just add them for now, and then I'll simplify. So f of x0 plus f of x1. Then I add the next one. Plus f of x1 plus f of x2. Right? Plus the next one. F of x2 plus f of x3. Plus the next one. F of x3 plus f of x4. Right? Make sense? Good. Okay. So now I'll simplify. 1/2 times 1 f of x0 plus 2 f of x1 plus 2 f of x2 plus 2 f of x3 plus f of x4. So if you notice, they're all multiplied by 2 except for the first one and the last one. Does that make sense? Because
Yes, because you don't have two, like f of x0 and f of x4.
Right. Because this one only shows up for this trapezoid, and this one shows up only for this trapezoid. But all the rest, this one shows up for this one and this one.
Yeah.
That shows up for this one and this one, and this shows up for this one and that one. So that's why I'm adding 2. All right. Now, very good. Okay, so we have the general form, right? And if I was given this function, I could do it, right? But rather than giving you the function right now and just like working it out, let's figure out the general form, okay? If I call this, instead of 0, I just call it A, and I call this B, right? And instead of saying I have n intervals, instead of saying I have 4 intervals, I'll say I have n intervals, then I end up with this. 1/2 times, first off, what would the height be? What would the width of these intervals be? It would
be A over 4.
Well, let's do a whole
It's
other.
B minus A over
Let's
4.
do another picture so you guys can see it.
Right? Was that right? B minus A over 4?
Yeah. So let's do another picture just so we don't get confused. Okay. Let's say I've got this now. This is A and this is B. And I have n intervals.
And you mean n rectangle?
No.
I mean n.
And trapezoids, yeah. Or they're called subintervals in your books, what I call them, subintervals. All right? Then what would my width be from here to here?
B minus A over N.
B minus A over N. Very good. Now I would end up with 1/2. So the area equals 1/2 times this height, right? B minus A over N multiplied by, let's use this form here, right? F of x0 plus 2 times f of x1 plus 2 times f of x2 plus ... right? Because I don't have 4 intervals this time, subintervals. I have an unknown.
So
plus 2 times f of x n minus 1, just to show that the one right before the n is also
because
doubled.
we started like 0 and 2.
Plus
Because the last one doesn't have a 2.
f of x n. The last one doesn't have a 2. Right? So this right here is your general equation to solving for the area under the curve with the trapezoid going. Cool. And another way of writing this, instead of saying area, would be like this. The area equals the integral from a to b of f of x dx. And is it exactly equal to it, class?
No, approximately.
It's just an approximation. So if I asked you to find an approximation for the integral from a to b of f of x dx using the trapezoid rule, you do this. Okay?
Yeah,
Use
we
that
write that
function.
one down.
Using the trapezoid rule would be the top function.
Yeah.
And the bottom one is your standard integral.
It's just showing that that area is an approximation.
Okay.
That's just an approximation of that integral.
If we have integrals, what's the point of the trapezoid? Like,
What's the point of the trapezoid rule if you have integrals? Well, first off, you're not always going to be able to get the integral. Like, if I gave you the cosine of x squared minus 3 to the e to the x, a whole bunch of stuff, right? You could plug a value of x into your calculator and get that value of that function at a certain point, but you may not be able to evaluate the integral. At least not without like a calculator that can do that, or a computer. That makes sense?
yeah.
Okay. So, for the record, this, generally speaking, is what your calculators do. They'll use the trapezoid rule and then use rectangles when they're evaluating integrals. Okay?
So
This is actually called numerical integration. Okay? This is, yes?
no, that was a
Okay. This is the way your calculator does it. Your calculator doesn't just magically figure out the integrals and draw a graph. Your calculator uses this and does this with, 800 million intervals, and it does it really fast, and then it plots it. So this is called numerical integration because that's how a calculator does it.
So
Numerically.
you think there's someone which was like a human calculator?
Okay, so let's do an example, shall we?
Can you can erase everything, but I have to write what's in that little bubble.
I'm gonna erase the right hand side of it. Okay. So let's use the function f of x equals sine of x. Okay. And let's use the trapezoid rule to approximate the area from 0 to pi of sine x dx. And we'll start with n equals 2. Okay? And we'll see what that gives us. So first we're going to want to plot. Yes? Yes. Take a pass. Okay? We're going to want to plot the sine function. What's the maximum height of a sine function? Regular sine?
1.
Where does sine start? When x equals 0, sine is
0.
Very good. When x equals pi over 2, sine is 1.
And when x's pi sign is 0. It's gonna look very good. Very happy about that.
Good job.
Thank you for.
Good job myself. I memorized it. So good job.
But he didn't teach it to you, so.
He didn't teach it. I memorized.
Okay, so
I love you. I
Alright.
love
n equals 2.
Mhm.
All right. So first,
0 to pi. Sorry.
what was that?
It says, no, the integration?
The interval is what?
No, it's from what's
my
the,
my equation. I'm going to do area equals approximately 1/2. And what's my interval?
Pi minus 0.
Pi minus 0
over 2.
over 2.
So,
Yes.
really quickly, what's the, okay, you see we have the interval up there, right next to f of x equals sine of x,
Mhm.
and to the right of that, what's a and b?
0 and pi. Okay. So I'll quickly draw my trapezoids. Now in this case, these trapezoids are actually just triangles, but you can still evaluate them the same exact way.
Yeah.
Right?
Yeah, I think
Alright, so we start with what?
so.
F of x 0, so it's just f of 0 plus, is it just 1 times or 2 times this form?
2.
2 times f of
Pi over 2.
pi over 2 plus, is it 2 times or 1 times?
1.
1 plus f of pi. Right? Okay. So simplifying, we have pi over 4. And then what's f of 0? 0. And then we have 2 times f of pi over 2 is 1. Plus f of pi is 0. Right?
Mhm.
So this ends up as pi over 4 times 2, which equals pi over 2. Okay.
Wait, wouldn't it be 2? The f of pi over 2? Oh, you did. No, I thought you just said 1 for the middle term.
Wait, what is
Yeah.
the pi over, pi over 2 times 1.
Yeah. Got that? And so that's our answer right there, right? For n equals 2. This is for n equals 2. Right?
Wait, what was n?
N is the number of subintervals.
Okay.
So I have 2 subintervals there. Right?
Yep.
Now let's do n equals 4. So if I have n equals 4, I'm dividing into 4, right? So it's going to be what? Pi over 4 for this one, and then this will be pi over 4. Okay, and then draw my intervals, or subintervals rather. It's called subintervals instead, so we don't have to say trapezoids every time. Just subintervals. So the interval is a to b, and the subintervals are what I divide that interval into. Cool? Alright. Obviously this should be symmetric at this point, but draw a picture a little bit and stuff, but it's okay. So n equals 4. Now, my area will be approximately 1/2. Did my interval change? No, it's still 0 to pi.
But
So it's
subinterval.
pi minus 0, but did my n change? The number of subintervals? Good. How many subintervals do I have now? 4. Very good. And then f of 0, just 1, and then 2 f of pi over 4, 2 f of pi over 2 plus 2 f of 3 pi over 4 plus f of pi. Everybody following this? Good. Okay. Yep.
Yeah.
Good. So, simplifying, I have 1/2 times pi over 4 is pi over 8. Multiplied by f of 0 is 0 plus 2 times, what's the sign of pi over 4?
Radical 2.
Radical 2, so very good. Radical 2 over 2 plus 2 times the sign of pi over 2, which is 1, plus 2 times the sign of 3 pi over 4, which is radical 2 over 2, plus f of pi, which is 0. Which gives us pi over 8 times, this 2 cancels with that 2, this 2 cancels with that 2. I have 2 times 1, plus radical 2 plus radical 2, so plus 2 radical 2. Right? So let's, someone get this in, we could simplify this and do a whole bunch of things, but let's just get this in decimal. Can someone do that in their calculator real quick?
1.896.
1.896. Alright. And can you do pi over 2 in your calculator real quick? It's what, 1.57. So it's so this one is 1.57 and this one is 1.896. Okay, do you guys see that the more intervals that I have, the bigger it's gonna get until it's almost exactly the area, right? Because I'm cutting off less and less from my actual area, right? Okay, good. So we got our final answer here, we got our final answer here. Pretty good. Now, what do you think would happen if I made it n equals 8? It would be bigger. Would it be closer or further away from the actual area?
Closer.
Closer, right? The more subintervals I have, the better, the more precise I am. Exactly. So, all right, cool. So let's find the actual integral now, because I think we can do that, right?
Integral of sine.
The integral of sine is what?
Cosine. I mean, negative cosine.
Negative cosine of x
Plus
c, but I'm evaluating. It's a definite interval, so I don't really have to worry about that. So from 0 to pi is equal to negative cosine of pi, right? I'll make the negative on the outside. Cosine pi minus cosine of 0, right? Okay, so this is negative, what's cosine of pi?
-1.
Negative 1, and then cosine of 0 is 1. So it's negative 1 minus 1, that's going to be negative 2. So this is positive 2. So the actual area is 2. The first time we got 1.57. The second one we got 1.896, right? So the area, the error got smaller and smaller. You'll probably want to watch this video. Okay, but basically what we just did is we found the area under function sine of x from 0 to pi. And at first we did 2 intervals, and we did the math here, and we got 1.57, and then we did 4, and we did the math, and we got 1.896.
Okay.
And the question I gave to the class was, would the area get closer or further away with more intervals, more subintervals, to the actual area? Am I going to get more accurate with more intervals?
You get more accurate.
More accurate, right? And then you could see, if I would add more intervals, would the area, do you think it would get bigger or smaller?
Bigger.
Bigger, right? Because I'd be cutting off less and less, right? So I first got 1.57, then I got 1.896, and then I found the actual integral in the area was actually 2. So I am, in fact, getting closer and closer as I go. Okay? Very good. All right, does everybody basically understand all that? Yeah? Good. All right. So that is it for the day. Any questions on that? No? All right. Very good class.